So let us begin our discussion on bisection method to discuss. Okay, so in bisection method, it is also called as bracketing method. So start with an interval. In bisection method, we must start with an interval, let's say any values, that is initial, initial values. We have to start with initial values with some interval. And I need to find out whether fa and function of, I will evaluate my function, whatever functions that is being given to us, I will evaluate this function at this initial value, and I need to um, see that these function values are opposite. Okay, so they have the opposite sign. So what way it will look like? This function should have, meaning of this is geometrically, if you want to see, let's say absence value, then this function fa, with this initial value, basically my interval, this is my interval, and bisection method is bracketing method. It is also called as bracketing method, BRACK, bracketing method. So you are bracketing two values. Okay, the two value may be, you are evaluating function here and you are evaluating function here, let's say f of b, functions value at, so this has to be, a and b, this has to be bracketed. That's the logic behind, bisection method. Not only bisection method, but there is also another method like false position, and some method in false position also, it's a bracketing method. We will try to see afterwards once we try to understand the geometrical interpretation of this section. So it is a bracketing method for finding zeros for the continuous values, and we must start with an initial value interval, that is the bracketed interval, and fa and fb should have opposite signs. Now I will tell you later on the some conditions which in this method has to be satisfied, and geometrically also we will try to understand. Okay, what is the logic behind this? First step in this method is, in bisection method, suppose my roots, this is my bracketed interval, and we need to systematically move the point either A or B in such a way that the interval is closer and closer together until we obtain an interval of an arbitrarily small value, small width, bracket 0. That means we have to squeeze from here, squeeze from here, squeeze the interval from A and B in. Okay, so we need to check this, that A and B comes closer together until we obtain an interval of very small bit, that is this A should come somewhere here. We try to squeeze B, and my bracketed interval will be very close to the roots that brackets 0. And how do we achieve this? So first step of this analysis in this bisection is interval halving process. Interval half means आप interval को half कर दो, a plus b by 2. That's the first step. So first step of the bisection method is process of having the interval that is to choose midpoint. C is equal to a plus b by 2. And then now a very important part is coming that you have to see. See, the first step I tried to explain you, because hypothetically, of course, and in reality also later on, we will try to investigate, we will try to see that hypothetically my roots are here, but my interval I started with here. That means I need to squeeze my interval. These two values a and b keep on changing in such a way that it is, give you the smallest interval which brackets the root, and smallest widths. So these interval width should be smaller and smaller. You have to squeeze it. And the first step, how can we achieve this? If I take the midpoint, a plus b by 2, I try to minimize at least the interval. But what are the conditions? I found out point C. I found out some point, but that is only one value, right? This is just the one value. But it's a bracketed interval. That means I need one more value, right? So one point I have figured it out, that is a plus b by 2. That's the midpoint. And this is the first step, that process of having the interval to choose first the midpoint, and then how to choose the second point, because a plus b by 2 तो हमने कर दिया, उसका जो value है that will come somewhere here. But what about the second value, that based on what I choose? So there are three possibilities. We will try to understand geometrically also how to choose the second point. Then there are three possibilities. So those conditions I will be writing here, and we will try to see, and then we solve one example, so that will just complete. Method is very easy to solve. I'm sure the problem solving is easy, but then this understanding part will be difficult. Okay, so if FA, all of you please note down, because then I will write and then explain you. FA and FB have, if FA and FC, see, FA and FB has opposite sign, that we have in the beginning itself we have assumed that FA and FB has to be opposite sign. That means it should cross. So mera bracketed interval should be such that FA and FB should have opposite sign. It should have opposite sign. Okay, so if FA and FC, now compare FA and FC, evaluate the function at first, of course, the middle step is evaluate function at point C. Point C पे function evaluate करना है और आपको उसको FA के साथ compare करना है. So if FA and FC have opposite values, have opposite sign, a 0 lies in A and C. It's obvious. Graphically, I will draw one more graph where you will be able to understand that. See, graphically, if this is your A and this coordinate is A and FA, this is your function y is equal to fx, and I am having b somewhere here, fb, and I have found out the middle point and also evaluate the function at value c, that is this has become now c, and c का जो function you have evaluated, okay, this point is fc. So these are the coordinates c and fc. Now if a and c has opposite sign, then we have to, of course, this is your a, this was your b earlier. Then we have to squeeze the interval from right. It's obvious. I can, so which value that I have to take as the second point bracketed in the bracket, then it is obvious that the 0 lies in A and C. आपका जो 0 है A और C के बीच में होगा. So next time when you try to evaluate the function with these bracketed values, which bracket that you have to choose, of course, it becomes B equal to C. This is very important. Okay, B becomes your C. तो मेरा जो bracketed interval है, instead of AB it becomes AC. Now if you try to compare FC with FB, that is second possibility. So this is your first possibility. Suppose now you are comparing FA and okay, I will just write the correct way. So if FC and FB have the opposite sign, then of course your graph is, I'll draw the graph how it looks like. This is your FC. The coordinates are C and FC. This is FA. And this is your BFB. So now this is the second possibility. If FC and FB have opposite signs, meaning of this is C is here, B is here, and A is here. So that means if this has opposite signs, then a 0 lies between C and B. It's obvious from this graph, right? 0 lies between C and B. 0 lies between C, B. This is the bracket. And in the process, how do we squeeze our interval? What is new bracketed interval? That you are actually squeezing this. So your C, A becomes C next time. When next time you are finding the function's value, you have to evaluate your function on these two bracketed values. Okay. So in the process, it becomes A is equal to C. A becomes C. So C की जो value है, पहले हम C की value evaluate करेंगे. First we will try to evaluate the value of C. If your value of C, you evaluate the function's value or with C, that is FC, you try to compare FC with FA and FB. So two possibilities we have seen. One is if you compare FA and FC have opposite signs, then a 0 lies in interval A and C. If this is the case, right, first case, then you have to squeeze the interval from B side, that means B becomes C. And second possibility, if FC and FB have opposite signs, then 0 obviously lies between C and B, that means you have to squeeze from side A, that is A becomes C. So next time when you evaluate, take this bracketed value, next time you take the interval halving process using these values. Okay, if either of the case is possible. And third case, of course, when if FC is 0, then the 0 is C, that is the root. So you need to evaluate, that is the last possibility, of course, if FC फंक्शन C की वैल्यू वहां तक हमें लेके आनी है जहां पे function's value should be 0, and obviously then the root is 0 is C, that is root is at point C. This is third possibility. Third possibility. So understood. Now we will solve one example. Then you will understand better. Okay, this is second possibility. Now we will try to see one example. So it is much more clear by solving it. Again, here we have to, if you have any doubt, just let me know, or then we solve one example. So we keep on searching new intervals continuously, which is interval is very small, which will give you the desired value, very small value. Bracket it, but the interval has to be very small, and then we at some point we arrive at some value of C, which will give you root itself, right? The function's value 0. Okay, so we will consider one cubic equation for solving our example. That is fx equal to x cube plus x square minus 3x minus 3 is equal to 0. Now just I'm just giving you the interval that is 1 and 2. So if x is 1, interval, I am choosing interval 1 and 2. So first what I have to choose? I have to check that this f1 and f2 should have opposite signs. ये मेरा पहला काम यही है. I need to see, in the beginning we have seen, right? First I have to see that this should have opposite sign. So we evaluate this function 1 cube 1 square 3 1 minus 3. What value you are getting here? I think calculator. Which value you are getting?
Ma'am, -4.
-4, yes, very good. And then you evaluate f2. So 2 cube plus 2 square minus 3 2 minus 3.
Ma'am, 3.
Okay, very good. So this is giving you 3. That means these two have opposite sign. So we have guaranteed roots between these two values. It is obvious that change in the sign in the function between x equal to 1 and x equal to 2 guarantees at least one interval. If you plot the graph, I don't want to plot the graph, but I'm just hypothetically telling you that if some graph is something like this, there is -4 here, and this is your function's value, but this is your 1 and 2. Okay, so somewhere here, 1 and 2. So bracketed interval, and we are trying to evaluate the one value is somewhere here, and second value is somewhere here. Below this one. So one here. Okay, so I'm just evaluating my bracketed values at 1 and 2, and functions value, functions crossing, this is your root. So my interval is 1 and 2, and functions value is crossing the x-axis. So guaranteed root between this 1 and 2. That's what we want to begin with our example. Okay, now we evaluate, you make one table, okay, and we try to find out the midpoint. Okay, that is, let me check one, x cube plus x square minus 3x square. Okay, so what we do is you try to make one table where it will be much more easier for you to calculate A and B. Then we have C, and then we have FA, FB, and FC. So finally, what is our target? This 0.0000 something, 0.0000 something, these values. Till we get these values, what is our root value of the C? Somewhere here is your root. So first we started with, we try to understand with a simple way. So first value we started with A value, that is 1, right? Second value we started with 2, that's a value of B. So this is your bracket, 1 and 2 is your bracket, right? So A and B value is read. Okay, what is C? C is A plus B by 2. Then 1 plus 2 by 2 is how much? 3 by 2, 1.5. So you write 1.5. Now evaluate all three values. Of course, these values you have already evaluated. That's, this is -4, this is 3. Now evaluate FC with this 1.5. What value you are getting, that you have to write it somewhere here. This is iteration number. Everybody will please practice, because then otherwise you won't understand things. So this will be iteration 1. I want to check, okay, what is the value of C? First value of C, and then you compare FC with FA and FC with FB. In bisection method, you have to compare these two possibilities, and based on that you decide whether value of A is C or whether value of B should be taken as C. That I will decide afterwards for the second iteration. Okay. So value of C, what is your what value you are getting?
Minus 1.87.
Yes, very good. Minus 1.875. Now, according to our two conditions, you may note down or write down if you can't do it orally or something. So, first possibilities. First, if FA and FC have opposite signs, a 0 lies in A and C and then B is equal to C. So, if FA and FC, you try to compare FA and FC first. If they have a opposite sign, okay, then B is equal to C. Just compare FA and FC. No, they don't have opposite sign, right? They have the same sign. So compare FB and FC. That is second possibility. They have opposite sign. Then what is the value of C? What is the value of your bracket? That is, if FB and FC has opposite sign, then A becomes C, right? That is the second possibility. Then A becomes C. Okay, so what will you write here? A value of A becomes value of C, that is 1.5 will come somewhere here. So this you have to keep on checking. It's pretty simple, I think, pretty easy. 1.5. So, and what value of B? It is as it is. And then find out the next value of C. So 2 plus 1.5 by 2. So understood, it is very logical. You have to compare this FA and FC first. Then you compare FB and F. If they don't have opposite sign. That means I can't proceed further. I have to choose a function, two values which has opposite sign. Then only I can tell my roots are lying between that interval. Okay, so these possibilities, if it does not have opposite sign, I rule out that possibility. Because you observe this graph, right? Because I need to have at least, if A and C should have opposite sign. Then if A and C does not have opposite sign, I rule out this possibility. Then check second possibility, that I compare FAC and FB. Okay, and compare, okay, this is opposite sign. That means I check. Then according to this graph geometrical interpretation, if FB and FC has opposite sign, that means you are squeezing the value of A towards C. That is, A becomes C, and that's what exactly we have chosen, that A becomes C, right? A becomes C. So next time what we have taken, your C value, your A value becomes C value. Now check the value of C and evaluate the next interval. I mean, value of C is what? 1.5 plus 2 by 2. So that is 1.75, right? This is 1.75. And evaluate FA, that is new value of FA using 1.5, new value of FB using 2, and new value of FC using 1.75. So all three values, all of you please calculate and give me the answer. Already evaluate कर चुके हैं. So वो value वहीं पे यही रहेगी.
मैम 3 और 0.171.
हाँ 3 0.1718. Yeah, correct. Okay, now observe again according to these, that this function have opposite sign. F A and FC has opposite sign. That means B is equal to C. So what value of C we have to choose as value of B, that is 1.75 somewhere here. So next time 1.75 for this third iteration, I have to choose, I have to compare these two values. See, FB and FC, this possibility will not occur because they don't have opposite sign. I want FA and FC, they have opposite sign. So perfect. A and C has opposite sign. That means I will have to look at this graph A and C. A and C has opposite sign. That means value of B I am squeezing as C. That is C value will become your B value next time. So I have taken this C value somewhere here. And your A value becomes as it is. Next time you take the same value as earlier value for the A and find out the value of C, that is 1.5 plus 1.75 by 2, 1.625, 1.625. And then this value, I think 1.75 value is already here. So 0.17 will come here because value of B is same. Okay, so 1.1718 is already here. So now you evaluate these two value, FA and FC. It's very easy. I mean, it's very simple.
FC minus 0.943.
Yeah, correct. Minus 0.923, 94 आ रहा है इधर.
943.
Oh, 943. Okay. Good.
Ma'am, FA will be minus 1.87.
Yeah, very good. Minus 1.875. Okay, so keep on doing this and just carry on these iterations, 4, 5, 6, whatever. Just continue the process. If you have not understood, just ask me. It's pretty simple. Just keep on comparing your intervals.
Till where we have to do the iteration?
Till you get zeros values somewhere for value of C. Sorry, not 0. Functions value should be 0. FC should be 0.
FC or F, A and B?
FC. FC, because that is the midpoint of interval A and B and that becomes your root. So C value आपकी रूट वैल्यू होगी. C आप वो इक्वेशन सेटिस्फाई करेगा C की वैल्यू जहां पे फंक्शंस की वैल्यू 0 आएगी. There can be only one root, right? One root value. There cannot be two roots value. So A and B cannot be taken as the function's value. Only one value, that is in the midpoint, because that is the point we are targeting, right? In the squeezing the interval and the midpoint, that should function's value should be 0 and the value of C is actually the root because it satisfies your function's value.
FB और FC तीनों की वैल्यू नेगेटिव हो तो
See, वो हो नहीं सकता है because see we in the beginning itself we have chosen our interval A and B should be opposite. Then there is no possibility of finding the root. Then root does not exist. See, in the beginning we have chosen our bracketed interval in such a way that it should have opposite sign. That means this process continues of you are getting opposite signs of two functions. That process continues. It should continue the process. I think we can check on a couple of more examples that I will be giving you in assignment. That time also you check that in the beginning itself we have chosen FA and FB should have opposite sign. If in the beginning itself we have not chosen, then we can't proceed, right? So you cannot proceed further. Ideally it should come.
मैम FC की वैल्यू minus 0.01 आई है.
कहाँ पे?
मैम 6th iteration पर.
हाँ
हाँ 0.0 थोड़ा डबल ट्रिपल जीरो पे लेके आओ।
हाँ मैम।
हाँ एटलीस्ट 3-4 डिजिट शुड बी 0, 3 डिजिट तक करो तो हमें पता चलेगा कि विच इज अ क्लोजर रूट। सी की वैल्यू क्या मिली?
1.7325।
7325 1.7325 करेक्ट है। 1.732 ये आ रहा है आपका वैल्यू 1.73205।
यस मैम।
Yeah, this is the answer. This is the final answer.